Hello, today we're going to go over Lab 1 for Physics 2212, in which we're going to talk about point and line charges. Here we have a content overview of what we're going to go through today, starting off with the introduction, going through the basics and fundamental principles used in the experiment, moving on into the computational models where we're going to show the codes obtained for each specific value needed in the calculations, such as gravitational force and electric force. Then we're going to go and move on into the results, which we're going to compare the results in the computational model to the results obtained by hand, and wrap it up with the answers to our additional questions and general discussion. Moving on, we have the fundamental physics principles, starting off with Coulomb's law, which we can describe as the electric force between two charged objects, and this force is directly proportional to the product of the quantity of the two objects divided by the distance between the two objects, squared. We have gravitational force, which is an attractive force used near the surface of the Earth, electric force, which is basically described through Coulomb's law, electric field, which is a force created by a small test particle, and this small test particle feels the force created by another charged particle, the line charges, which are a collection of point charges arranged in a line, and an electric field superposition, which basically states that electric fields can be added into the vector form, and these ones do not affect or block one another. Here we can see the relevant formula used in the experiment, which is very self-explanatory, but if you want to look at it more, feel free to pause the video. For the experiment setup and data, we took tape B and set it up at the top of two bases, and tape A, which was set up below tape B. The length for tape B was of 0.22 meters. However, the exposed area to tape A was of 0.133 meters. This length was used in all calculations to calculate gravitational forces and electric fields. However, this could also be a sign of human error, and if the experiment was done again, the length of the entirety of tape B could certainly be used for calculations. Feel free to pause the video to look at the rest of the data used in this experiment. Moving on, we have the computational models. In this slide specifically, we were focusing on the code for the gravitational force. However, in the next slides, you would see the codes relevant for the electric forces as well as the electric forces in the line charge model. To your right, you can see the free body diagram of the forces acting on tape B, which are all in the y direction. We have the gravity, the force due to gravity, as well as the electric force due to tape A, which you can also notice that they are same in magnitude but opposite in direction. Then this model that you see here is specifically for the point charge calculations, and all the values that we saw in the previous slide, such as length, mass, as well as distance between tape A and tape B, were inputted in the code to obtain the gravitational force. On this specific slide, we can see the code used to calculate the electric force on tape A due to tape B. Again, if you want to see the electric force and the gravitational force on tape B due to tape A, feel free to pause the video and go to the previous slide. In this specific slide, we want to focus on the calculations done to obtain the magnitude of the electric fields. We know that the forces are equal to an electric field times the charge of the particle that we're analyzing. So, in order to obtain the electric field, we just rearranged the equation and divided the force by the charge of the particle of interest. Below, then, you can see the calculations done to obtain the charge of tape B. The other model analyzed was the one in line charges, in which we did not assume that the tape was a single point charge. Here you can see the changes done to the code to obtain the gravitational force as well as the magnitude of the electric field for a line charge. Here we have a snapshot of the program outputs. To your left, you have the model obtained for the point charge model, and to your right, you have the model obtained for the line charge. It is important to remember that for the line charge, we assumed 100 point charges in the line, which just made the calculations more accurate. Here we have the results done by hand to calculate the charge of a point charge model and the charged particle in a line charge model. The main difference between the two are the equations, because the basics are the same. We both assume that the force of the gravity and the electric force are the same in magnitude. However, the difference, as stated before in the denominator, is that the line charge adds up the distance between the charges to the length of the tape divided by 2, raised to the second power. Other relevant results for this experiment were the number of electrons and the number of atoms. For the number of electrons, we took the charge calculated before and we divided it by the charge of a single electron. In this case, the number of atoms was a little bit more complicated. However, we assumed that tape B had a thickness of 1 length scale atom, and then we divided the area of a tape by the area of the 1 length scale atom. Below, you can see the ratio between the two. Some assumptions for this experiment were that the U-tape had the same amount of charge distributed along the length of the tape. We also know that the gravitational force and the electric force are the same in magnitude but opposite in directions, will help a lot with the calculations. And because the tape B is static, the air resistance in this experiment is irrelevant. To finish up, we have the answers to our additional questions. What if the electrons were positive and the protons were negative? In this case, there will be no change to our observations or results because the physics conventions remain the same. And why are the values for Q different in each model? Simple. The models are already different on their own. And the line charge model is closer to the real value because it demonstrates all the charges or point charges in the line, which the line in this case is the tape. Thank you for your attention, and I hope this video was helpful in understanding point charges and line charges.